Good morning, class 11. Let's start. Hydrides. Hydrides are binary compounds of hydrogen with other elements. There are three types of hydrides. First, ionic or saline hydrides. Next, molecular or covalent hydrides. And third one is metallic or interstitial hydrides. Ionic hydrides are formed by combination of hydrogen with metals which are highly electropositive in character. Some common points are: first, ionic hydrides are generally white or light grey, non-volatile crystalline solids. They behave like salts and are referred to as salt-like hydrides. However, beryllium and magnesium hydrides, they have covalent polymeric structure. They have high melting and boiling points. The binary hydrides of alkali metals have rock salt-like structure. They conduct electricity in fused state, liberating hydrogen gas at anode. The thermal stability of hydrides of alkali metal hydrides decreases from lithium to cesium hydride. They are readily hydrolyzed by water to produce hydrogen gas. Lithium hydride we are taking gets hydrolyzed to form lithium hydroxide and hydrogen gas. Now the aqueous solution of ionic hydrides, they are basic in nature because of the generation of hydroxide ion. Now this particular reaction is explosive in nature and the fire produced cannot be extinguished by carbon dioxide gas because ionic hydrides react with CO2. So the fire produced can only be extinguished by sand. Ionic hydrides behave as strong reducing agents. Like sodium hydride reduces carbon dioxide to sodium formate, or I can say it reduces lead sulfate to lead sulfide, etc. Next, some hydrides, they are also used to prepare complex hydrides of other metals. For example, lithium hydride reacts with aluminium chloride to form lithium aluminium hydride plus lithium chloride. Now this lithium aluminium hydride generated, it's a powerful reducing agent. It helps in the reduction of aldehydes, ketones, carboxylic acids, esters, cyanides, etc. It's a strong reducing agent. Next we move to molecular or covalent hydrides. These hydrides are formed by combination of elements of comparatively higher electronegativity as of p block elements. Now the bonds formed here are mostly covalent in character, but in some cases, like for example in HF, ammonia, H2O, the bond is partially ionic in character. The hydrides have molecular lattices, so the molecules are held by weak van der Waals force of attraction. In some cases like in HF, NH3 and H2O, intermolecular hydrogen bonds are present, due to which water, ammonia and hydrogen fluoride possess abnormally high boiling points. Common points are: they are soft, they have low melting and boiling points and are generally volatile in nature. They have low electrical conductivity. The properties of the covalent hydrides depend upon the electronegativity difference between hydrogen and the atom bonded to it. For example, ammonia is a weak base, water is neutral, while hydrogen fluoride is acidic in character. Next, we come to the classification of molecular hydrides depending on the electronic configuration of the central atom. First, we have electron deficient molecular hydrides. In this particular part, the central atom has incomplete octet and they usually form polymeric structure. For example, BH3, it has incomplete octet, okay, and it is present always as B2H6. It undergoes dimerization. Okay, so it is the example of molecular hydride which is electron deficient. Next, we have electron precise molecular hydride where the central atom has complete octet, means its octet is fulfilled. Example, I can write methane, carbon tetrachloride, etc. Last one, electron rich molecular hydrides. Now this type of hydrides where the central atom contains a lone pair of electrons. For example, ammonia and water will be coming under this example. Water In water, oxygen atom has 2 lone pairs, and in ammonia, nitrogen has 1 lone pair. Okay, next we move to metallic hydrides. Most of the D block and the F block elements, they form metallic or the interstitial hydrides. For example, scandium hydride, lanthanum hydride, etc. Now, beryllium and magnesium, which belong to S block, also form metallic hydrides. The common points here, first, they are hard, have a metallic luster, conduct electricity, and have significant magnetic properties. Next point, these compounds are non-stoichiometric and their composition varies with temperature and pressure. Now first, these are the common points. One thing just I'll mention, in this particular part, means these hydrides they are known as the interstitial compounds. Why? Because the hydrogen atoms occupy the interstitial positions in the metallic lattices. That's why they are termed as the interstitial hydrides. And hydrogen, basically due to the small size, they prefer to occupy the interstitial position. So that's it, class 11. Thank you.